Hello, my name is Nimisha and I will be presenting a patent on reversible cipher invented by Gregory Scott Calen. A reversible cipher device is a cryptographic device which performs reversible encryption and decryption using transposed Sudoku filter and pseudorandom mixing bits. This invention includes methods and apparatus for stream-type block ciphering. Let us look at the methods used for securing data. A method of securing data includes receiving a plaintext data unit, encrypting it with a transposed Sudoku to form a first ciphertext. Further, encrypting this first ciphertext with pseudorandom mixing bits gives us a second ciphertext, which is outputted using the data selector. The data selector essentially gives out a cipher bit, which is XORed with plaintext to form the ciphertext. Another method is that of decrypting the ciphertext. The third ciphertext is generated and given to the transposed Sudoku for encryption to form a fourth ciphertext. This fourth ciphertext is then encrypted using a pseudorandom mixing bits to form the second plaintext corresponding to the third ciphertext. Now, in order to receive the correct plaintext from decryption method, it is important that the mixing bits used for encryption and decryption be the same. Any change in value, polarity, evenness, or the position may lead to a different ciphertext that does not match the corresponding plaintext. Now, let us look at the apparatus for stream-type block ciphering. A cipher device includes an input register, a Sudoku filter, and a data selector. An input register contains a number of data bits corresponding to a data unit element. In this example, the input register is configured to include a 1x6 grid or an array of numbers. In general, it can include 1 by n array of numbers from a payload. Now, the Sudoku filter is coupled with the input register and the data selector is coupled with the Sudoku filter as well as the input register, shown with red lines. Given that the input register is configured to include a 1 by n array of numbers, the Sudoku device may be configured to contain 1 by n minus m values, where m, a subset of n, includes the number of selector lines going to data selector. As shown, 0 and 1 are the select lines and 2, 3, 4, 5 are the inputs coupled to Sudoku filter and data selector. The cipher device may contain more than one mux or data selector from which the cipher value is output. Now, cipher device also contains a working memory which can be used to store intermediate values, variables, and pointers during operation. It also includes a process control unit, PCU, to manipulate instructions and values in respective elements. Process control unit is operably coupled with input register, Sudoku filter, mux, and working memory. Another apparatus in a FOB configuration includes an input port, an FPGA coupled with input port, and an output port coupled with FPGA. These three elements are configured as a FOB device. Plaintext is received at an input port, FPGA performs the task of encrypting this plaintext, and the corresponding second ciphertext is transmitted to the output port. A cipher device can also be configured to have input and output ports as a USB port and a memory device coupled with FPGA. Now, let us look at a flowchart explaining the ciphering scheme. Let us call it a cipher file. A typical cipher file flow can proceed by initializing parameters, selecting a Sudoku list, opening input and output ports, and reading an input data unit for enciphering. If a data unit is not available for enciphering, the method proceeds by closing input and output files and indicating completion. If a data unit is available for enciphering, then the method proceeds by performing the cryptop operation upon the data unit to create a first ciphertext, and by performing the cipher operation to apply the pseudorandom mixing bits to the first ciphertext, thereby creating a second ciphertext data unit. If either of the encryption routines encounters an error, throwing and announcing an appropriate error message is performed. Otherwise, writing the second ciphertext data unit into an output file precedes reading the next input data unit for enciphering. Let us now look at cryptop and cipher operations. The left-hand side code explains cryptop used for encrypting the plaintext using transposed Sudoku, and the right-hand side explains cipher used for encrypting using pseudorandom mixing bits. In cryptop, the Sudoku accesses the input register as scrambled by the pointers SDKO and PSDKO. The output from the filter array is passed to the data inputs of at least one data selector or multiplexer. The multiplexer has selector inputs provided from the remaining bits from the input register as scrambled by index. The output from the multiplexer is the cipher output. Cipher may be described as a pseudo-random number generator operation, which may be used to encipher plain text or to decipher ciphertext. Variables SDKO and PSDKO may be transposed, and then operation turns over to the cases of a switch statement. Each case statement embodies one of the 10 or 16 filtering functions of the Sudoku. Once bits are assigned a mixing value, elements of a password may be encrypted into a ciphertext message. This was Reversible Cipher patent explanation. Thank you.